Hi guys, most students and teachers don't know how to draw the Haber cycle. Today I'm going to show you how to draw it. Please subscribe to my YouTube channel. Draw the Haber cycle for calcium oxide, and from the Haber cycle you have drawn determine the lattice energy of calcium oxide from the given information below. You have been given we have been given enthalpy of atomization or atomization energy of calcium, have been given first ionization energy of calcium, second ionization energy of calcium, dissociation energy of oxygen, first electron affinity of oxygen, second electron affinity of oxygen, and enthalpy of formation of calcium oxide. Now, the Haber cycle is drawn from down upward. Now we have to write the reaction equation. The elements which are reacting, calcium plus oxygen, but you have to leave enough space between the plus sign and the metallic element, and plus sign and non-metallic element. Now, indicating the physical states, of the elements which are reacting. Now, then after that, take your ruler, then draw a horizontal straight line. Then after that, you have to go to rough paper and then write the reaction equation. Calcium plus oxygen to form calcium oxide. But you have to remember, know that the oxidation, the valence of calcium is 2, while the valence of oxygen is 2. So when they are combining together, they tend to exchange their valences. This valence of this is 2 is written as a subscript of oxygen, while the valence of oxygen is written as a subscript of calcium. Then after that, this is the product form. But you have to simplify the ratio. This is by 1, 1, by 1, by 2, 1, by 2, 1. So the product formed is calcium oxide. This is a solid. So you have to balance the reaction equation. But when you are balancing the reaction equation, the product formed must be 1 mole. Conserve the product formed to be 1 mole. Why? Because the Haber cycle is drawn to determine the lattice energy for 1 mole of ionic compound. So, on the reactant side, 1 calcium. On the product side, 1 calcium. On the reactant side, there are 2 oxygen atoms, but on the product side, there is 1 oxygen atom. So we have to put a half as a stoichiometric coefficient of oxygen in order for oxygen to balance. Now then after that, we have to put a half here. Then after that, these are the standard substances. Being standard substances, they exist, they have low heat of formation, which is 0 heat of formation. 0 heat of formation is a very low amount of heat energy, which cannot make them to react. They cannot react while they are at standard form. So in order for them to react, they have to absorb a series of heat energies from environment. Now, the metallic element, we have to deal first with the metallic element. Then after the metallic element has reached an extent to react, we shift to the non-metallic element. Now, when you are drawing the Haber cycle, you have to know that the arrows for heat energy released to the surroundings should be pointed downward, while indicating that the heat energy is decreasing, while the arrows for heat energies absorbed from environment should be pointed upward, showing that the heat energy is increasing. Now then, after that, you are not allowed to write anything. You are not allowed to write anything in front of this horizontal line. Other students and teachers tend confused. They tend to write the product calcium oxide. Don't write. Why? Because by writing the product in front of this horizontal straight line, this indicates that the product formed has a heat of formation which is equal to the heat of formation of the reacting element. The heat of formation of this reacting element is 0. So by writing this product in front of this horizontal straight line, it indicates that the heat of formation of this product is 0, something which is not correct, which is not true. So don't write the product in front of this horizontal straight line. Then after that, we have to start dealing first with the metallic element. Then after the metallic element has reached an extent to react, we shift it to the non-metallic element. Now, calcium element is broken down to gaseous atoms. It is atomized to gaseous atoms. This is half oxygen gas. Now, gaseous atoms. Then after that, you have to draw a horizontal straight line. Horizontal straight line indicating that the chemical species are in the same energy level. Now, this is heat change 1. Heat change 1 is atomization energy, which is the positive 177 kilojoules per mole. Then after that, calcium has not reached an extent to react. So in order for it to reach an extent to react, it must absorb another amount of heat energy, which is called first ionization energy. This is gas plus electron plus oxygen, a half gas. But calcium loses 2 electrons, but the 2 electrons are not lost at once, but they are lost in steps. First electron is lost, then followed by losing the second electron. So in this step, the first electron is lost. This is heat change. This is heat change 2. Heat change 2, first electron affinity, which is positive 590.1 kilojoules per mole. Then after that, it has not reached an extent to react, so it loses the second electron, calcium. Second electron is lost, plus a half oxygen. This is a gas. Heat change 3. This is equal to, heat change 3 is equal to positive 1110.3. This is a kilojoules per mole. Second ionization energy. Now you have to draw a horizontal straight line indicating that the chemical species are in the same energy level. They are in the same energy level. Then calcium has reached an extent to react. Now we have to shift to non-metallic element. Don't draw the arrows for a non-metallic element. We are dealing first with the metallic element. Now we are done dealing with the metallic element. Now we shift to the non-metallic element. Now, this non-metallic element, which is oxygen, is atomized. It is atomized to 1 mole of oxygen atoms, 2 cancelling out, remaining with 1 oxygen atoms, with 1 mole of oxygen atoms. Now this is a gas. This is a gas. This is a heat change 4. Heat change 4. Heat change 4. Heat change 4. This is we have been given the dissociation energy. Dissociation energy is the heat energy which is required to break down an element in molecular form to form 1 mole. This is the heat dissociation energy. Is the heat energy required to break down an element, 1 mole of an element in its molecular form to form moles of gaseous atoms. If it is a diatomic gaseous substance, the moles of atoms which are formed will be 2 moles of gaseous atoms. Now, this is dissociation energy, but the energy which is used here is not a dissociation energy, but it is atomization energy. So in order for us to get the atomization energy which is used here, we have to have the dissociation energy we have been given. Have the dissociation energy we have been given. Now, why? Because atomization energy is equal to a half dissociation energy. So have this dissociation energy in order for us to obtain the atomization energy. Now, this is equal to heat change 4. Heat change 4 is halved in order to obtain the positive 4, 7.80 kilojoules per mole over 2. Thus, calcium. Don't draw an arrow here. Why? Because this has reached an extent to react. It does not absorb any more heat energy at this point. That's why we are not drawing the arrow at this stage. Then after that, we have to draw a horizontal straight line indicating that these chemical species and these chemical species have the same energy level. Then after that, oxygen atoms formed are very unstable and they cannot exist. They are very unstable. They cannot exist. In order for them to obtain some stability, they have to gain electrons lost by calcium. Now, oxygen accepts electrons lost by calcium, but oxygen gains 2 electrons, but the 2 electrons are not gained at once. They are gained in steps. Now, the first electron is accepted. After accepting the first electron, heat energy is released to the surroundings. First addition of electron to the neutral atoms is exothermic process. Why is it exothermic process? It is exothermic process because the electron is being attracted by the nuclear attractive pole of this atom. There is no any repulsive force. That is why heat energy is released to the surroundings. Now, oxygen accepts 1 electron to form a mono negatively charged gaseous ion. This is a gas plus calcium. Now, the metallic ions may be written in front of non-metallic ions, like this one. This is a gas. This is a gas. Then after that, this is heat change. This is heat change 5. Heat change 5 is equal to, this is the heat energy, heat change 5. Heat change 5, this one. This is the first electron affinity, which is negative 149 kilojoules per mole. Kilojoules per mole. Then after that, oxygen has not reached an extent to react. It must absorb another amount of heat energy. Another amount of heat energy in order for the electron to be added. Remember that the second electron is going to be added to this chemical species which has already gained 1 electron. It is negatively charged. Now, when the second electron is coming, there is a big repulsive force between the first added electron and the second coming electron. Due to like charges, as you know, according to laws of electrostatic, like charges repel. The first added electron is negatively charged particle, and the second coming electron is negatively charged particle. So there is a big repulsive force between the two. So, in order for the electron to be added here, amount of heat energy must be supplied in order to overcome the big repulsive force existing between the two. Now, so the heat energy absorbed must be absorbed to overcome the big repulsive force. So the overall heat energy is positive. It is positive because it is the heat absorbed from environment. Since it is positive, its arrow must point upward. It must point upward, like this. Now this is oxygen. It has gained 2 electrons now. This is a gas. Plus calcium ions. This is a gas. You have to draw a horizontal straight line indicating that the chemical species are in the same energy level. Then after that, this is heat change. This is heat change 6, and the heat change 6 is second electron affinity, which is equal to positive 7.9.6 kilojoules per mole. Then after that, now calcium ions and oxygen ions are ready to combine. They are ready to combine. So since they are ready to combine, when they are combining, a certain amount of heat energy is released to the surroundings. That amount of heat energy released to the surroundings is called the lattice energy. It's called the lattice energy. It's called the lattice energy. But since it is the heat energy released to the surroundings, its arrow should be pointing downward. Now, we don't know the product is formed below this horizontal line or above this horizontal line. This horizontal line indicates the energy level of the reacting element, which is 0. So this indicates that heat energy is 0. Now, we don't know where the product is formed. But in order for us to know where the product is formed, we have to look at the heat of formation of the product, calcium oxide. The heat of formation of calcium oxide is negative 636. Since the heat of formation is negative, now the product, which is the calcium oxide, is formed below this horizontal line. Why? Because this horizontal line indicates 0 heat energy. So it is formed below the 0 line because it is negative. But if it were positive, the product would be formed above this 0 line. But n number above 0 is positive. N number below 0 is negative. Now the product calcium oxide is formed below calcium oxide. This is it exists in solid form. Now then after that, this is heat change. This is heat change 80. It is heat change 80. Heat change 80. But then after that, we have to draw a straight line, horizontal straight line from the end of the page up to this up to the end up to end of the page. Then after that, this is the lattice energy. Heat change 8 is lattice energy. Then after that, this heat amount of heat energy, the difference between the energy of the reactant and the energy of the product is called heat of formation. It is called heat of formation. It is called heat of formation, which is heat change 7. Heat change 7. Heat change 7 is the enthalpy of formation, which is negative 60 kilojoules per mole. So this is the first root. This is root 1. Root 1. While this one is root 2. This is root 2. Root 2 consists a series of energy changes from here, from this point, up to all this series. It gets root 2. Then from Hess's law, Then from Hess's law, enthalpy change in root 1. Enthalpy change in root 1 is equal to total enthalpy change in root 2. Enthalpy change in root 1 is equal to the enthalpy change, to the total enthalpy change in root 2. Now this is, but enthalpy change in root 1 is the heat of formation, which is heat change 7. This is equal to the sum of the series of heat changes, heat change 1 plus heat change 2 plus heat change 3 plus heat change 4 plus over 2 plus heat change 5 plus heat change 6 plus heat change 8 plus heat change 8. That is the end. Then after that, enthalpy formation is negative 6360. This is equal to heat change 1, positive 177 plus heat change 2, 590.1 plus heat change 3, positive 1110.3 plus heat change 4, 497.80 over 2 plus heat change 5, which is negative 149 plus heat change 6, which is equal to 789.6. Then plus negative 149 plus positive 789.6 plus heat change 80 plus heat change 8. Then after that, Then after that, the sum of the heat energy is 2766.9 plus heat change 80. This is equal to negative 60. This is the positive. Negative 6. Then after that, like terms on one side, on the same side. This is like these terms are like. So make heat change 8 the subject of the formula. This is equal to negative 6360 plus will change to negative after crossing the equal sign. Negative to 766.9. This is equal to negative 0. This is equal to negative 3402.9 kilojoules per mole. Hence, the lattice energy of calcium oxide is negative 3402.9 kilojoules per mole.